In this video, I introduce a foundation role model for generative interactive environment. Generative interactive environment is a foundation role model, which is trained on unlabeled internet gaming videos in an unsupervised manner, and can be permitted to generate a variety of action controllable virtual worlds described through text, synthetic images, photographs, and even sketches. Compared to the world models, Genie Foundation world model is trained only on internet gaming videos controlled by learned frame-by-frame latent actions without action or text annotations. As shown here, these three types of prompts, X, Y, generations, conditioned on the previous frame and the latent action. A Genie model consists of three components, namely a latent action model that infers the latent action A between each pair of frames, a video tokenizer that converts raw video frames into discrete token Z, and a dynamics model that, given a latent action and a pass frame tokens, predicts the next frame of the video as shown here. The Genie model is trained in two phases, namely the video tokenizer is first trained to produce frame tokens as shown here. And then the latent action model is trained directly from pixels to generate the latent actions as shown here. And the dynamics model is trained on concatenation of the video tokens and the latent actions to generate the future frames as shown here. This input video, this generations, this video tokenizer, this latent action model, and this dynamics model. The latent action model obtains the latent actions by conditioning each future frame prediction on the action taken at the previous frame. The latent actions are learned in an unsupervised manner by understanding the frames in a video and the latent actions hidden in the video. The latent action model encoder takes as input all previous frames x1 to xt and the next frame xt plus 1 as shown here, and outputs a set of continuous latent actions A1 to AT tilde. A decoder then takes all previous frames and latent actions as input and predicts the next frame xt plus 1 tilde as shown here. Vector quantization variational autoencoder-based objective limits the number of predicted actions to a small discrete set of codes. As the decoder only has access to the history and latent actions, A1 tilde should encode the most meaningful changes between the past and the future for the decoder to successfully reconstruct the future frame. Spatial temporal transformer, as shown here, is used as a latent action model. The causal mask in the temporal layer allows us to take the entire video x1 to xt as the input and generate all latent actions between each frame. The video tokenizer converts the videos into discrete tokens to learn video representations. For example, T frames of video x1 to xt are mapped to discrete representations Z1 to ZT as shown here. The video tokenizer is trained using the VQ variational autoencoder objective over the entire video sequence. The dynamics model is a decoder-only transformer, which at each time step t uses Z1 to ZT minus 1 and stop gradient latent actions A1 to AT minus 1 tilde to predict the next frame talking ZT caret as shown here. SD transformer uses tokens from all t-1 frames Z1 to ZT-1 and the latent actions A1 to AT-1 tilde as input to produce all next frames Z2 to ZT caret. The dynamic model is trained with cross-entropy loss between the predicted tokens and the ground truth. At the training time, the input tokens Z2 to ZT-1 are randomly masked according to the Bernoulli distribution mask rate sampled uniformly between 0.5 and 1. The dynamics model uses as an input the concatenation of the action at the time t and the tokens of the corresponding frame. The trained Genie models can generate action controllable video at inference time. The model is first prompted with the image x1 as an initial frame that is tokenized as z1, as shown here. A discrete latent action A1 is then obtained by choosing any integer value within the codebook. The dynamics model takes the token Z1 and the corresponding latent action A1 tilde, which is obtained by indexing into a vector quantization codebook with the discrete input A1 to predict the next token Z2. This process is repeated to generate the sequence Z2 to ZT caret in autoregressive manner as tokens continuous to be passed to the model. When tokens are decoded into video frames, X2 to XT caret with the tokenizer's decoder as shown here. Metrics of Genie model include video fidelity that indicates the quality of video generation using Fairchild video distance, and controllability that indicates how much impact the latent actions have in video generation using peak signal-to-noise ratio. For more details, please check with these references. Thank you. Bye.